I promise you this relates back to what we did yesterday. Most of you, I keep saying most of you, I don't know why. Some of you might know that my hobby is woodworking. So I made this chessboard, but more impressive than that, there's pieces here, whatever. If you're into chess, come talk to me at some point. Sadly, there's not a lot of time to play chess. So if I get a chance to play chess, Nevin has already called dibs on getting to play me. At the end of the year, like in Q4, we tend to have a lot more free time. So my AO and my extensions aren't normally slammed then, or we should figure out my days that I don't have a war in here. That's when we might do to play chess. I love that acronym. It just makes sentences so fun. I am your war. So there's an old story.
You could do raw though.
We thought about it.
Raw. Why did you do raw?
Well, because then if you put foundations with it, because we were debating, could it be Wharf? And aside from that, it's like far or words that are very hard to say. So there are reasons. Yes.
When you go home and tell your parents you're sad because we did not have war today.
Right. There was no war today. So there is a famous story that I'm going to try to do a tiny bit of justice to. So this is like a parable. I'm not like teacher making this up. This is a parable that you may have heard before. So there was a king, like a story. There was a king, and I forget in what country, but we'll watch a video about it in a minute because they tell the story better. And he was a chess enthusiast. So when travelers would come to his kingdom and come to his castle, if they challenged him to play chess, he was always all about it. Yep, I'm great. I'm going to beat you. Got it. So a traveling sage comes to his castle one day and says that challenges the king to a game of chess. So the king says, all right, well, if you win, what would you like? Because the king was, kind of cocky, and he was one of those like, I beat everybody. So the sage said, all I want is rice. And the king said, well, that seems like a pretty modest request. And the sage said, all I need is 1 grain of rice on the first square, 2 grains of rice on the second square, 4 grains of rice on the third square, 8 grains of rice on the fourth square, 16 grains of rice on the fifth square. So what's happening with the rice? It's doubling. So the king agrees, says that seems very modest. He says, we might need some rice here, but I'm probably going to win. And they play. The king loses. So the king orders his people to bring some rice, and they, on the chessboard, start to count out the rice. My question for you is, by the time they get to the bottom end of the chessboard, how many grains of rice will be on the final square?
A lot.
So if you are unaware, and if your eyes are hard at observing, a chessboard is 8 by 8. So 8 by 8 is going to end up with how many squares?
64.
64. I promise you, I'm not a terrible math teacher. Now, yeah, don't fall into the trap door. 8 times 8 is 64.
Wait, the first one has 1?
The first square just has 1 grain of rice.
It's 1 to the
Work.
16 per power.
Work with your team. Well, that answer is just 1.
Yeah.
Work with your team to figure out how we could calculate. And then, hold up. When you try to then say, oh, well, that's bad word. What's the total amount of rice? Not just the last square. What's the total? Take a couple minutes to talk with each other. It's not my chessboard.
Yes.
I mean, I guess.
I will give it back.
Thank you.
He's not working.
That was one of my COVID projects. I was like going stir crazy at home, so I built a chessboard. You want to see the pieces?
No, this was one.
This is the bishop.
Oh.
So my next set, I ordered magnets, so the next set that I make, I can put magnets into.
And then you can stick them on.
Yeah, so I was just super bored, so I made that set. I see what Brenda's doing. I would love to solve the math problem. How long will this take, Brenda? Yeah, thank you. Woodworking is just my hobby. I don't have any kids. I got a lot of saws though. Hey, Jesus isn't involved here. Just the king. Different king.
This is probably got
No!
This is my own
Get a pair of scissors too. Probably yes, so it's easier to.
We have a business activity that we'll probably after this that is kind of the same thing. Different numbers and a different comparison. And you'll see when we do it, but one is broken. And the other starts at 2 cents. So we just pay scale and we actually pay scale.
Yes, we do.
Whoa, what is this E? There's an E involved. The knights you say? Can we not do this? Because we're going to end up all over my room and the custodians already have a ton of work to do. And you're going to have to cut out, like, I don't know, 1 trillion dots. So, I wouldn't. I'm sorry. I wanted to let you go for a minute to have your fun. No, we're not doing that. The custodians already have enough work on their plate.
I have so many things I need to watch.
Sorry to burst your bubble.
Mr. Hudson, what is the E?
It's a letter of the alphabet.
He is a variable.
Let me see this. E is not a variable. Well, it could be, but normally capital letters aren't being used as variables. So do not make that assumption. So, Gus thinks the answer is 5. Gus thinks the answer is 5. E 17.
What?
Yeah, 9.2 is 9 power.
What?
I don't know how Gus got his. That's what he thinks. Spence? Wait. Is that what it means? How did you figure that out? On your graph paper, and I don't know that this is the answer. On your graph paper,
What is it?
Maximilian, we should have out 811 and we should have out graph paper, please. Thank you.
I already did it 811, but I will get it.
Thank you, sir. I know 811 wasn't here for some reason. Patrick is gone again.
I gave him tomorrow.
He disappears
I know.
I know.
He's recruiting new.
Draw.
He's recruiting me.
Hold up. Hey, draw on your paper a square.
Okay.
You don't have to make it 8 by 8, but if you want to, you could.
What lesson is this?
It's 8.1 point question mark is literally what the start slide said. 8.1 point question mark.
He's right!
Augustus is another very solid name.
Augustus? Yeah, he was a guy in Greek or Roman.
He was a guy in Greece.
He was in Greek.
It's all Greek to me.
Hello, culture. I am Maximilian.
Alright, not quite square, but I can fit it all on here. So if you want to make yours 8 by 8, go ahead and make yours 8 by 8. If you want. Sure, take a second to draw this. Now, so we've got 64 squares on our chessboard.
So 8.1 point question mark?
Yeah, literally, because we're going to do some 8.1, but then also some 8.8. 8.1.2. But it kind of depends. I'm letting this content be a bit more free-flowing because you guys are interested in this, and it'd be silly for me to go too fast. So, whatever, optimize. What's what? Now, I don't think I really actually want to write out all these numbers. I think I'm going to use math to be more efficient. If can I rotate this? Will it fit any better? I don't know that it fits any better.
The coefficient is 15 times 2.
All right, so you got your chessboard?
No. Wait, no, I still need to color in the little spot.
Every single one.
So on the first square, we said 1, 2, 4, 8. Careful. Trap door there because you're going to want to say 6. 16. 32.
128.
So I'm already bored. I'm already bored.
That's 25th.
So wait, hold up. That's not even half the board. So, Walter, what is it that... Hey, bring it back. You had a few minutes, bring it back. Walter, what is it that we're doing from number to number? We're taking our number and we're multiplying it by 2. Now, we started talking yesterday because this is new, not new content for you, but new for us to have talked about it this year. I want to do times 2 times 2 times 2 times 2 times 2 times 2 times 60 sometimes. I don't want to write out 60 some 2's. What could I use instead? Colin?
Exponents.
Why?
Because it's just multiplying by itself. So, like, 2 squared is 4. 2 to the third power is 8. And then you can just keep on doing that so and so on.
So yes, except I want to correct how you said something. An exponent is telling you how many times we multiply the base. The base. So be careful. Because saying by itself, if this is a different number, right, it gets a little, what is itself? Right? So we're taking the base and we're multiplying as many times as the power tells us. So what number did we start with?
A big number.
2.
1.
1, right? We just started with a 1. And then if I do this all the way down the board, how many times have I multiplied by 2?
63.
Ooh, Brenda, why are you saying 63?
Because you already had the 1. Oh, mine might be 1 so big. You did the 1, and now it's the 2. So now you just want to multiply it by 2 63 times instead of 64. Because if you do 64, that's 1.
To get to the 8th square, we have doubled 7 times. Right? 1, 2, 3, 4, 5, 6, 7. So it's actually 1 less multiplication than we have squares. Because remember, it's how we move. Right? It's how many squares do we move. Max? I think, I got more. And you guys need to restock your binders, but I got more. Like, I went to the supply closet. I have more on my desk. I can restock the jar. So, I think they're not over there with erasers? You guys are all easy to scavenge. No, there's one there. I mean, I'll give you a new one, but you gotta sharpen it then. So it's either you get one with an eraser or you get one that's sharpened.
This one's so small. Nasty with all the wood shaved off. Like this one.
If you're gonna be particular about your pencils, maybe bring your own. So we're going to do this 63 times. Now, on your calculator, as some of you have come to ask me about, some of our calculators... Oh, crap, somebody stole my yellow one. Some of our more simple calculators versus some of our graphic calculators. And actually, I'll show you all 3.
33720.
Hey, Jake, are you helping or not right now? Are you helping right now? No. We got all 3 calculators that most of us use. Now, on this calculator, there's a nice squared button. Too bad we're not squaring here. Same on this calculator and same on this calculator. Right? It shows us x squared, which actually does not mean x squared. If I type in a number and hit the little square button, it'll need a second to focus on my screen. Or it might not, because I got so much stuff going on here. I am. Thank you for asking. So I don't know if we'll be able to see it on this screen, but if I hit 5 and hit the little x squared button, it's not squaring x, it's squaring the number we typed in. Right? So that will be 5 times 5, get 25. But if we want to raise our values to any power, Gus, do you want to tell people since I taught you at lunch?
The carrot. It's like that little thing that looks like an up arrow.
The caret, the little, now be careful because there is an up arrow on this calculator, but the caret here, or the caret here is how we can raise a number to any power. So if I type in 2 caret 63,
I was off. Dang.
darn Gus, you were slightly off.
Yeah.
Now on, just by a tiny bit.
Yeah.
So if I type in 2 caret 63 on one of these fancy pants calculators, I get an E that comes up on my screen. However, your immaturity is showing right now. Please try to get yourself in check. On this calculator, it's actually nicer. It tells me it's times 10 to the 18th. So if you have one of the fancy calculators, E does not mean an exponent of that number. So I don't know if I'll be able to get this to focus again. It means the exponent of 10. So on our paper, let's go ahead and write down, we got 9.22337.
This king's gonna be a
Wait a minute. I'm
2, 3, 4, 5,
confused.
6, 7.
Why is it times, like, why is it in decimals? If it, like, 2 is larger than...
Because your calculator,
The 16 is larger.
your calculator is essentially, you know, on like the cartoons or whatever, where like smoke comes out the ears of somebody when they think real hard or whatever. Your calculator is saying, this is way too big of a number because what 9.2233, I mean, you can put as many of these decimals as you want or don't want, but then it's times 10 to the 18th. What that tells us to do is multiply by 10 18 times. So this real number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18.
Oh, that's gonna fight you.
Whoa.
Decimal goes here. So let's figure out how to even say this number.
Quintillion.
It's a lot of rice.
So hundreds, right? Thousands, millions, billions, trillions, quadrillions, quintillions. Guys, and we started at 1. Max?
Theoretically, by the time the guards are done counting out all of those, there would have been the guards would have died and their children would have replaced.
Well, funny you should say that.
Oh,
Actually,
God.
they're like games have you double every time it gains double. I knew that. I knew because it's not just gonna be like a.
Because it's not a straight line. Yeah, there's these other types of graphs, right? Jordan, you seem very worked up. Are you rapping? You were like throwing hands for a second. You looked like you were rapping. I don't know that we'll have time to get to that Desmos because I committed that we would look at homework for a second because there's a couple problems we need to go over. So there is your quick intro to essentially the thought process behind
Oh, thanks.
compound interest.
Oh, wow.
This is the difference between simple interest and compound interest.
Now, just imagine how many Brendas that is. That's
Max, rein it in. Bring it back. You need to talk to her and see if that's funny or not. And if not, we're going to leave it. You're cool with it?
Yeah, I'm good.
All right. So, looking at the homework real quick. because we still haven't gotten through 811, but we should talk about the homework. I've solved a lot of these problems with people at Math Lunch, so pull out your 811 if you don't still have it out, but I think you do. Yeah. So remember, rate. Guys, this is a misnomer. So give me your eyes up here real quick. A couple of people brought me wrong answers. I have yours right here. Colin, I have yours. But turn it back in because I haven't put the chapter 8 grades in my book yet, so turn that back in. I put a check on it, but didn't put it in my grade book yet.
Mr. Rice, if you times that number you said 355 billion,
Yeah.
it would be 7.1 times 1026.
For what?
26
What's
pounds.
that the answer to?
The amount of pounds. Not
Oh, if we actually compute it out. So, here's a trap door from the homework. You do not use the actual number that's in front of your percent, because what does percent mean? Out of 100. So when we go to calculate this and actually compute the value, we use 0.04. We put it in rate form. Guys, I have a personal issue with them saying rate of 4%, because we would normally only say 4% or a rate of 0.04. But if I'm being honest with myself, these are all equal numbers. It's like they're allowed to say that. It just bothers my brain because this is what we talk about as rate form. So same thing in number 8, right? Make sure that 4% you're using as 0.04. In 8-9, the main questions that people brought to me are just like, hey, wait, what are we computing? We're computing the percent change. So it's the amount of change divided by where we started. Brenda?
Would it be around 5%?
I don't know. Put that in your calculator and you probably.
I put
Yeah,
it in my calculator
seems right.
and it was like around.
A tiny bit under 5%, I think.
Yeah.
I think a tiny bit under 5%.
So I just said around 5.
I got a
Yeah.
little over 5.
8-10 is what we really need to talk about.
Why?
Because you were in Math Lunch and that's why you know what to do, but other people might not know what to do. 8-10 is asking us to factor these binomials. Now what's tough about that with a binomial is, can I add 4x with 8? No, because that's why it's a binomial. They're not like terms. So when we factor them, we look for what is the greatest number that I could divide both of them by. With 4x and 8, it probably jumps out at you. That number would be 4. So we divide by 4 to both of them. And then we rewrite this as 4 times, what would we have left? X plus 2.
Oh, I did that.
Nice.
That's what I thought it was like, it was talking about distributed property, and then it said
It's
factor.
undistributing is essentially what it's doing.
And it said it was
That sounds so
expression
weird, though.
multiplication of factors.
Just making it harder. Why would
So
you do
what
that?
can we undistribute? Don't worry, we'll loop this back to why it matters. This is just practicing the skill. What can we undistribute from -5 and -45? -5, right? It's kind of the first number we said. So then what would we have left?
-5x plus 9.
9 plus 8.
9 plus x, if we keep it in the order they had it.
Why would you do that? That's just making it.
It's just the order they had. Why would we factor out? Because there are a lot of cases where taking out the greatest common factor actually makes the problem easier to solve. If you want the real answer, stop in at High School Math 2 at some point and help us factor a quadratic formula.
That
Yeah.
sounds like
What time is it?
Exactly.
That sounds like
2B.
2B.
Or not 2B.
To be determined.
All right.
2B.
We should now, and I apologize to you guys, but then I also apologize to Mrs. Hunter about how bad I was when I wouldn't tell you the answers here. Remember, relative frequency table. We total the entire thing and turn it into percents. So what's our total of all these? Is it 100? Did it work out nice?
No.
I don't think so. I mean, it'll be 100%, but I don't think these add up to 100.
I thought 98.
The inside of the...
98.
Maybe? Yeah, 98.
Yeah.
That's what I got. I think that's right. I'll do double check. I got
15,
98.
13. Yeah, we're probably too short of whatever. We're too short of a 10.
It's 98.
Okay. So then we turn the whole thing into percentages. So here, we do 29 divided by 98. Hey guys, one of the reasons I'm going over all of this is so when you turn it in, if you don't have this stuff actually done, you're getting a check minus. Because we're at that point in the year where if you're phoning it in and only giving me half effort, that's not good enough. Nevin?
For this, it says on it that consider the number of activities the independent variable. So, are we doing the 100% being the bottom rights, or are we doing the 100% being across the rows? Because I did across the rows because I thought the number of activities is the independent variable.
So what I want you to get used to is putting the total 100% out here. You can, and this is why we continue in this circle talk of why this is tricky. You can do whatever you want with the table. But if we want to make it, crap, and this is why, this is not actually relative conditional, so what you did is probably okay. I mean, we can pull up the answer key if we really want to see what the key gave us.
Wait, isn't this
Ooh, these the answers, Mr. Hudson.
I don't even know if you have this worksheet yet.
Andrew
You don't even
recorded it?
I have it. I got it during math lunch.
Absolutely right, yeah. So I was thinking of the next homework, right? So Nevin's got it right. Since they tell us the independent variable here, and it's not a conditional relative frequency table, they just have us make a relative frequency table. Sorry, I inserted conditional. That is going to 100% across this way. So my bad again. My bad again. We're 100%ing this way. There you go. Now, if you did conditional relative, I'm fine with that. If you did conditional relative, that's fine.
Yeah, Mr. Hudson.
Yeah.
If we do have the thing tomorrow, how do you say it? If we do have the thing tomorrow.
What's the thing?
The homework's still due. It's the homework 811, 812, 813.
I mean, really, especially now that we've gone over it, 811 should be able to be turned in today. If not, it's not a big deal. But, like, yeah, if you're done with it, turn it in. Yeah, and then scale factor would either be 3/2 or 2/3, depending on which way you're going. 3/2 or 2/3.
Can I get a candy for reminding you?
Reminding me what?
You just
You told me to remind you about one thing.
Did you notice how, like, my slides were in order with what I wanted to cover? Sort of like when you come in and say, hey, make sure you record, and I say my software's already open. It doesn't mean I forgot.
I know,
It
but
just means that
still.
you remembered.
See, I never remember to remind you though, because you always already have it open by the time I remember to remind you.
I dislike when teachers just make you memorize stuff. And always, when I tutor kids, hey, give me like 2 more minutes maybe. Like, I'd really have 4 more minutes, but give me like 2 more of your focus. Why we call the second power squared and why we call the third power cubed is because, I mean, do you want to teach it? I don't care.
No, I don't.
Lily?
Oh, we learned about this.
Is because, can I use the board so option?
Alright, thank you. We learned about this, Mr. Hudson, so I can give
Well,
you
yeah,
more
when we were at
time.
math lunch.
What?
God,
That's how
you
you
erased
erase
it.
That's because math lunch is so awesome.
You don't like my cube?
Is it a bad cube?
You can just start a new page if you want.
So are you on 2-dimensional? You have 2 axes, you know, and then you get a second.
Who's like making noise?
Yeah, third axis.
Thank you for stopping.
You get a third axis, and so you square it. You have.
Can I help?
Yes.
Because I got a little bit of practice at this.
Yes,
What
please.
Lily's trying to say is absolutely right. When we were in 2 dimensions, we have like X and Y, right? We have like width and height, or whatever you want to call it. when we get into a third dimension, and this might actually be really helpful, my math art people know where I'm going with this.
Is it X, Y, and Z axis?
You have to go towards the plant like
Oh, this.
When we get into 3 dimensions, what we're literally saying is the volume of this shape is the edge length cubed. So if I sketch a cube, right, I didn't sketch it very dark, so you might not be able to see it super well. Here, I'll give it some more color. Normally, if you're sketching in 3D, anything on the back side of the shape, you make dotted. Because it kind of helps us see this. What's the edge length of this cube that I drew?
A lot.
3. So my base would be 3 by 3, and that would be 9. My height would be another 3. So the volume of this is going to be 3 times 3 times 3. Or the other way we say that is 3 cubed.
Wait, what is
This is why... Can you please stop talking over me? Raise your hand if you want to talk. This is why squared, the second power gets a name, the third power gets the name cubed, and beyond that, we just say like 4th power, 5th power, 6th power. Jake?
It looks like one of those things you call 6.
When we all talk at the same time, it's real hard. Grant, thank you for raising your hand.
Wait, so I'm just wondering, is power by 1 just a straight line?
Yeah, power by 1 just means I just have one of those numbers, and it's not even really multiplying by anything. There's just one of them. So like this length is 3 to the 1st power, right? Like this edge is 3 to the 1st. Lily? You guys should remind me to tell you about Flatland. That's a very interesting thought experiment. If you want to grab any more worksheets, do that. Then clip them in your binder and have a wonderful day. Just take like 2 at a time, friends.
Did you know if you had a 3DS and you turned 3D mode on,
What,
close
3DS?
Yeah.
What's 3D?
Sorry, 3DS is Nintendo.
Oh, can we go?
You got me.
Okay, it's a thing. And
It's a thing.
And if you close your, and it makes it 3D by having 2 images slanted.
Is it like just a trick with your eyes, or do you have to wear like glasses, or what?
No, it's a trick with your eyes.
Now I'm kind
But
of really
if you
curious.
close one eye, it will come.
Because you only see like one of the screens or something. I don't know if I want to play that. I feel like it'll mess up my eyes.
No, you
Wait, are you talking about 3DS?
I guess we are. I don't know what it is,
It's
but
a Nintendo.
This is a map as missing, but
yeah, I've been having some map issues recently because it logs out.
This is what I did. I got all the
Leave
way.
it here with me. I'll give it back to
I
you
got all
later.
the way to 48.
Holy snap! That's awesome.